This is our group member, Wan Nur ADILAH as project manager, DAHLIA and AINA MAHMUDAH as network engineer, and then SAKINAH as security engineer, Ikmal as system administrator, HASSAN as database administrator, and SYAMILAH as documentation specialist.
Hi, Assalamualaikum. My name is SAKINAH binti Muhammad TARMIZI. I will present my part and I will start with introductions. The radio server infrastructure project aims to establish a secure and scalable authentications, authorization and accounting system. Designed to meet enterprise security needs. It ensures reliable network access controls through integrated authentication service, comprehensive monitoring and robust backup solutions. The primary objective of the infrastructure including: first, establish a centralized authentications mechanism for network access control. Second is integrating with enterprise directory service for unified user management. Third, implement comprehensive monitoring and logging capabilities. Fourth, ensuring system reliability through the robust backup and recovery procedure. And lastly is providing control environment for testing and validations. In our group, we have our personnel and roles. Me as a security engineer. You can see now the operating system we use is Digital Ocean Clouds. For the network device simulations, we using a 3 VM server, which is all the 3 server have the same spec detail, and then the architecture diagram here, which is we using VPN and go through internet for machine 1, machine 2 and the machine 3. And as you can see, the listed here the OS, and then we using public IP and also the private IP listed here. For the project components, the key activity is Radius is a networking protocol that provides centralized authentications, authorization and accounting management for secure network access. Is verified user identities through the method like password, certificates, challenge response protocol, ensuring consistent and secure authentication. By integrating with the external source like LDAP, radio centralized access control across the network. The key features of the radio server have 3, which is first, centralized authentication management. Process all the authentication requests from network devices, support multiple authentication methods in one place, validate user credentials against local and LDAP databases. Second is authentication protocol support, which is support PAP, CHAP and EAP for flexible authentication testing, and also enable diverse client device configuration and security level assessment. Lastly, for the key features is directory service integration, which is authenticate user against a centralized LDAP directory, implement group-based access control and policy enforcement, and simplify user management for testing and validations. Next is the common use case of the radio server, which is we have 3. First is a network access control testing, which is validate user authentication process, test access policies and group-based restrictions, and simulate various network access scenario. Second is security policy validations, which is assess user access right and authentication failure, enforce password policies and security rules, and monitor and log access attempt for compliance. Lastly is integration testing, which is verify LADP authentication and network devices, testing monitoring tools integrations, which is Grafana and use. And lastly, ensure reliable backup and recover procedure. How radius work? We have three phase, which is first authentication phase. User credential are forward to the radius server. Second, in authorization phase, user permission are checked in LADP. Access policy are applied based on the configuration. Lastly is accounting phase, which is login attempt, session duration, and access failure are recorded. The benefit of using Radius, we have three, which is centralized access management, is reduce administrative overhead with a single control points, ensure consistent authentication and authorization across network devices, minimize security gaps by unifying access control. Second is the enhanced security. We using standardized authentications, protocol and encrypted communications. Support secure password management to prevent unauthorized access, and provide detailed login and audit trails for security monitoring. Lastly is a flexible testing and policy implementation, which is support multiply authentications methods for diverse scenario, integrate with various network devices for comprehensive testing. Lastly, enable policy validation without affecting production environments.
Hello. Hi, everyone. All right. Now I will proceed with domain controller and LDAP. So for domain controller, or we call it DC, it is a server that authenticate and authorize users within a network domain. It enforces security policies and ensure only authorized users can access network resource. Then for LDAP or lightweight directory access protocol. So this one is a standard protocol used to query and manage directory information. It helps in retrieve user credential, organizational roles, and access right. All right. So domain controller and LDAP. For this slide, I will show how it works. All right. For domain controller, first centralized authentication and user management. And then second is enforce group policies and access control. And then third is manage domain-wide security. Okay, for LDAP, first is verifies user credential, meaning username and password before granting access. And then second is determine user permission and what resource they can access. And then lastly is LDAP is enable hierarchical organization of directory object like an organizational hub. As for domain controller and LDAP, so understanding LDAP in domain controller. Okay, authentication flow. First, user enters login credential, and then second, DC receive requests and queries Active Directory via LDAP, and then third, if valid, user gains access. If invalid, access is denied. Then key LDAP operation. Find for authenticate a user, and then search to retrieve user data, and then lastly is modify to update directory information. Okay, that's all from me. We proceed to next slide.
Hi, my name is Daahlia binti Muhammad Noor. Today I will discuss the role of the file server NFS, which is network file server, in our project and how it ensures efficient, secure and centralized storage for critical system data. So the purpose for file server, the file server using NFS act as a central hub for storing system logs, configuration files and backup. It enables seamless file sharing across multiple machines while maintaining data consistency and security. Okay, let's move to configuration details. First, the NFS share setup involves defining mount points and setting access permissions to control which user or devices can read or write data. Next, we use storage allocation and quota management to ensure that no single user consumes excessive resources, keeping the system balanced and efficient. Okay, for performance optimization, to improve NFS performance, we implement caching, network tuning and load balancing to minimize delays and enhance response time. These optimizations are crucial for handling high traffic environment. Next is backup and security. Integration with backup systems allow us to create automated snapshot and recovery plans, ensuring data reliability in case of failure. Additionally, security hardening measures such as encryption, access control lists, and firewall restriction protect sensitive data from unauthorized access. Next, we move to network device simulation setup, which help us validate reduce authentication across different network environments. For purpose, network security relies heavily on proper authentication and access control. Our simulation environment helps us test how radius authentication function across various devices like routers, switches, and a wireless access point before deploying in production. For key components, first we have virtual network devices. We use visualized routers, switches, and firewalls to mimic real-world network infrastructure, allowing us to test without physical hardware. Next, we have authentication scenarios. Various login and access scenarios are tested, including valid user authentication, fail at login attempt, and multi-factor authentication verification. For load testing capabilities, to ensure stability, we simulate high user loads on the Radius server, testing how it handles thousands of concurrent authentication requests. Next, we have error condition simulation. We introduce failures such as incorrect credentials, expired password, and network outage to measure how our system responds and recovers. For the last, we have performance benchmarking. Using benchmarking tools, we analyze authentication speeds, response time, and system bottleneck, ensuring our network meets performance expectation.
Okay, now we will explore how Prometheus and Grafana works together to create a robust network monitoring solution. These tools provide a deep system of observation, helping us track performance, detect abnormalities, and respond proactively to the issue. Okay, okay, take a look at each tool individually. Okay, for Prometheus, it is an open source of monitoring and alerting toolkit built for reliability and scalability. It collects metrics from designated targets at set intervals, store them at time series data, and processes this data to trigger alert or generate additional insight. Okay, on the other hand, Grafana is an open source analytics and visualization platform. It's connect to various data sources, including parameters, and present metrics through customizable dashboard. This makes monitoring more interactive and intuitive. Okay, Prometheus come with several powerful features, including a pool-based architecture where it scrapes metrics via HTTP, then a time series database for efficient storage of collected metrics, a powerful query language from QL that allow data analysis and manipulation. And then service discovery support, enabling seamless adaptation to dynamic environments. Lastly is about built-in alerting capabilities, helping teams react quickly to critical incident. Okay, for the key features of Grafana, now we discuss about what made Grafana a valuable additional to the monitoring stack. Okay, first, it's offer flexible, customizable dashboard for visualization, and then support multiple data source, including Prometheus, InfluxDB, and many more. And then provide rich visualization options such as graph, heat map, and tables. And then enable alert creation based on specific visualization threshold. Okay, lastly is include annotation and user management features to improve collaboration. Okay, on this slide, how Prometheus and Grafana work together. By combining Prometheus and Grafana, we create a comprehensive monitoring solution that handle the entire process from data collection to visualization. Okay, for Prometheus, collect and store metric efficiently, and then Grafana transform the raw data into actionable insight through dashboard. Okay, together they provide a seamless way to monitor system performance, detect abnormalities, and maintain optimal network health. Okay, thank you.
Assalamualaikum and salam sejahtera. My name is AINA MAHMUDAH binti AZRIN. Will present backup and recovery and also test client. This is backup and recovery. Backup are essential process to protect critical system data from accidental loss, corruption or failure. A well-structured backup strategy ensure data to securely store and can be quickly restored when needed. This process automated backup from Prometheus and Grafana, keeping them organized and removing all files to manage storage efficiency. And then recovering. Recovering is implementing an automated backup and recovery system enhance data security and reliability. By scheduling regular backups and managing storage efficiently, organization can prevent data loss and ensure seamless recovery in case of system failure. The step of backup: first, connect to virtual machine (VM), logging into the virtual machine remotely using SSH to set up and manage the backup process. And second, create backup script. Involve writing a bash script to automate the backup process ensuring data to copy and manage without manual intervention. Third, set backup directory. Involve definiting and backup recovery and creating folder based on the current date to keep backup organized. And then copy data. To copy backup file from Perimeter and Grafana, directories the backup location. And then remove all backup. Ensure the all backup are automatically delete after 7 days to free up storage and keep the system efficiency. And last, automate with cron job, meaning scheduling the backup script to run automatically using cron job. This is a test client. The test client components focus on validating two primary aspects of the Radius server: authentication capability and network connectivity. This client operate within the DigitalOcean VPC environment, performing essential testing to ensure the Radius server function correctly. First, authentication testing. Verify user authentication against Radius server. Test credential validation through LDAP. Confirm authentication successful or failure scenario. Validate user access, level and permission. And then connectivity testing. Test network reachable to Radius server. Verify communication path through VPC network. Ensure proper response from authentication request. Validate network routing and access path. Testing process is to process client initiated connection to Radius server, send authentication request with test credential, verify Radius server response, confirm network connectivity status. This focus testing, a push ensure to Radius server is properly accepting authentication requests, network paths are correctly configured, authentication service is functioning as expected, system response are appropriate and timely.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ikmal bin Johari. I will present about demo of this Radius server infrastructure project. Okay, first of all, we do this project for cloud environment. This apply for VM1, VM2, VM3. These servers consist of Radius, LDAP and NFS for VM1. VM2 consists of monitoring for Grafana and parameters and also backup recovery. The third is a test client to do the testing for all services that apply in this project. Also, we also deploy this domain for the authentication of the LDAP and the implementation of the LDAP. So we can see here there's a IP inside here. It's a public IP. When we deploying these servers by using this create and this, it will show here. It represent a few resources like 1 gig of RAM and also 1 CPU, then 25 gig of SSD and also 1000 gig per second for the transfer speed. Also apply for the others. But the thing is, if once it's deployed, it will auto assign the IP. It's assigned by the VPC. There's also the connection for the private IP for these three to connecting each other. Okay, for all the services, we need to allow the ports. We don't need to applying on the VMs. It's very headache. Just go to the monitoring. To the networking, the firewalls. Then we already rename as Radius FW. Then from here, there's a rules that we can apply inbound and outbound. So for standard is SMP SSH, the TCP UDP. Then we apply for each services. For radius, 18121813. For LDAP is 389, and then the NFS 2049. Then for Grafana parameters is 3000 9100. And also the source, you need to confirm that the subnetting is the some sub range of the VPC. Okay, that's all. Later on, we come back for Indonesia for the radius, LDAP, and also the NFS.
My name is ADILAH. I will be presenting our network design simulation project that we have implemented using DigitalOcean cloud infrastructure. Let us start with our VPC setup. We have established a VPC named VPC Radius server located in DigitalOcean. The VPC is configured with a subnet range of 10.104.0.0/20, providing us with 4087 available IP address for future scaling. So within this VPC, we have deployed 3 components. First, our primary services server, Ubuntu Primary Service 1. This server has a private IP of 10.104.0.2 and a public IP of 167.203.187. It dedicated to running our radius application service, which is crucial for network access control. So, second, we have our support services server, Ubuntu support services 2, with private IP 10.104.0.3 and public IP 159.223.83.243. This server hosts our Zabbix monitoring solutions, allowing us to maintain comprehensive network oversight. So, finally, we set up the test client Ubuntu test client 3, assign private IP 10.104.0.4 and public IP 152.42.215.186. This client server as our testing endpoint to validate network connectivity and radius authentication functionality. This architecture provides us with general advantage, which is a complete network isolation through the VPC, a secure internal communication via private network, external accessibility when needed through public IP. Last but not least, room for expansion with our generous IP allocation. Thank you.
Okay, now let's do the testing of the radius server. Okay, I need to copy the IP of the VM1. Alright. Okay, let's remote into the server. Key in the password that is set earlier. Okay, the server is ready to go. Okay, next. As you know that the Redis server already configured and deploy the implementation and so on. So we just need to do some verification. Okay, just that's the systemctl status for the Redis. Because of this is the Linux environment. We use Redis server application is free Redis. So just check whether all done. So we can see here it's already enabled and active running. So we can see here there's all the authentication is working. Okay, next we wrong command. So we check the text editor. We need to verify the client and user. So we can use Nano, we can use Vim, both is fine. Okay, now we enter all this thing. Radius, the version 3 and the client config. Okay, you can see here there's a configuration has been done, the local, the subnet range and also the IP for the sub. Okay, we can see here there's a secret phrase is testing 1 2 3. Not much. Then we go to the user configuration. Okay, the path is same. That's only changing from the 3.0 is users. Okay, we can see here we already has users being created and configured. Okay, I need to exit from here. Then we need to do testing of this Redis. Okay, that accessing to the free Redis. Just run free Redis -x. Oops, where is my X? Okay, sorry about that. You can see it's already entering the services of free Redis. Okay, now do one testing for each users. Okay, let me copy for the command for easy. Okay, we do the red test, the user, the password, the localhost and the port, don't forget, then the secret phrase. Okay, now we can see here the authentication is good because we see here is accepted. I'm sure the other 3 users also getting the same output. Yes, so we go for Ali. Then for user Mila. Alright, so we can see here the Redis server is pretty fine. Then should be no issue. And then next I share about this LDAP and also NFS. Alright. Okay, now we move on for this LDAP function. Okay. Now we're gonna do some because we has been done. Now we do the testing to search user. Okay, as we can see here, when I run this command, so it showing the LDAP functionality. There's a radius also. There we can see the users. There's groups as well. So we can see Ikmal J under users, and this the domain. This is the ID, display name, and same also to the other 3 users. You can see here. Okay, how about we do some search? Of this user. Okay, with this command, then we run it, and we can found SYAMILAH user. Okay, then we go for the group. Okay, so we can see here there's a group, only one group. Alright, so I think that's all. Not much to present for the LDAP because of some limitation of the password is not being established. Okay, thank you. Okay, now we're focusing on the file server. We're using the NFS service. Okay, we already configure for both client and also server. So just quick checking using the system safety as status of the NFS kernel. Okay, it's working fine. Now next, we actually has already not copy, already create the directory. Okay, go inside, check. So there's one file. Maybe we can do some folder, for example. Run. Okay, we has one file and one directory. Okay, now let's do the mounting. Okay, now we try to mount. Okay, now it's successful. To verify, let's check inside. Okay, so whatever inside here already transfer to the client side. So it is successful. Thank you.
Good day, sir. My name is SYAMILAH Ali. So I will be presenting the VM2, which consists of monitoring tool and backup recovery. So basically, for monitoring tool, we have two things: Prometheus and Grafana. So Prometheus functions as data collection. It grabs metrics from configured targets, store time analysis, time series data, collect system metrics, and handle metric data storage. And then for Grafana, it functions for the visualization. So it creates interactive dashboard, deploy metrics in various graph types, offers real-time data updates. So why we are using both? So basically, Prometheus handles the back-end operations, while Grafana provides the front-end interface. So together they create a complete monitoring solution. So for the Prometheus, we are going to use this website where we have already done config everything. So go to the target. So we have two things: primary services and Prometheus. So the most important thing is at the state. So we can have the yellow, red, or green one. So this one stating up and green part, which indicates successful connection towards VM1 and VM2. So that's it for the Prometheus. Next, we go to the Grafana. So Grafana is here. We did the dashboard, CPU and memory. So we can see system load, CPU usage, memory usage, disk usage, and network traffic. So basically, for the system load, the baseline loads remain low between 0 to 0.3. So it indicates healthy. Basically it's around here lah. 0.0. It's around this area. This is the spike. So around this area, 0.07. So it indicates healthy system performance. So it also has periodic spikes reaching 0.3. So it shows temporary increase in system activity, but it shows a quick recovery after spike, indicates good system responsiveness. We also shows the CPU usage. So the usage maintains around 1 to 2%. So we can also see several notable spikes, but then generally we can see it's have low utilization, indicating sufficient CPU capacity. We also have memory usage. So it fluctuates between 40 to 40. You can see 41.5. So gradual increase from 40% to 41.2%. This one gradual increase lah. So basically, it states a stable baseline around 40.5% around this area, showing consistent memory management. We also provide disk usage monitoring. So it shows steady increase from here, 9.8 towards 9.95. Yeah, so it shows gradual upward trends, indicates systematic disk usage growth. It also shows no concerning spike or sudden changes. Lastly, we have network traffic. So we have two distinct traffic patterns, which are the blue and the green one. So the blue line is primary traffic, while the green line is secondary traffic. So the blue one averaging between 1500 to 2000, and the green one average between 700 to 1000. So regular spikes 1, 2, 3, 4. So it's a regular spikes. Minimal Ethernet interface. So that's it, I think. So this comprehensive monitoring setup effectively captures system performance metrics, showing a healthy system with predictable resource usage pattern, and good handling of periodic load increases. So I think that's it for the network monitoring. We also have backup and recovery. So for this part, we are going to the terminal. So we are going to root VM2, the password. This is basically a very simple backup thing, because I'm backup the data using Prometheus and Grafana. So this is the backup. We have three things: roots, Grafana, and Prometheus. So for Prometheus, we can see multiple stamps, 20th February, 21st February. So at 5:23 hours, 3 hours, 5 hours. So it indicates regular backup. And then for the Grafana, we have the main configuration file. You have LDAP configuration and provisioning. So this one, we also have a Grafana data backup. This is the Grafana backup database file. So this is the database file. It also consists of CSV, PDF, plugins, and PNG, saying that the backup and recovery is in progress. So I think that's it for my part. So my friend will continue with VM3. Thank you.
Today we want to test first I will set up the free radius client on VM3, starting with SS root. So we key in the password, then to install free radius, update packet list. After that, install free radius, then create a test user script, add radius to perform basic radius authentication test for several user. Then test EAP deals with for the connection. Next, test connectivity. And then step 5, create EAP TLS configuration for testing, and add the requirement setting such as SSD, authentication method, identity, and radius server details. Step make a script executable. So the script executable was next, install and config Zabbix monitoring agent. Set the IP and host name. Last but not least, start and enable Zabbix agent. Then check the status of the agent. That's all.
The conclusion for this project is the radius server infrastructure project deliver a robust, secure, and well-monitored authentication solution adherence to industry best practice, and also ensure the centralized access control, strong security measurement, and seamless integration with enterprise system. There are three challenges and limitations, which is first, integration issues, which is ensure compatibility with the various network devices and authentication methods. Second is security compliance, maintaining encryption standard and prevent unauthorized access. Lastly is performance optimizations to managing authentication requests efficiently under high network load. For infrastructure environment challenges and solution, we also have three. First is virtual machine limitation. The issue is a network topology constraint, prevent a proper subnet communication. And the solution is the shifted from a hypervisor based setup to a more adaptable deployment model. Second is a Docker implementation challenge, which is the issue is a complex overlay network configuration, network isolation affecting radius traffic, and inconsistent network state after content restart the solution is migration to the cloud-based infrastructure for the better connectivity and scalability. Lastly, a cloud-based solution, which is digital oceans. The challenge is resource management optimizing compute resource for the cost and performance, and also network security, which is implementing cloud-specific policy and firewall. Thank you.